So today we're going to be talking about, very briefly, a brief overview, about automated testing with pyATS. Now you've already learned something today. It's not pyATS. For my first 8 months using this tool, I was talking about pyATS, and Cisco. I wasn't even with Cisco at the time. They reached out to say, we love your enthusiasm and we love that you're using our tool. Could you get the name right? So it's pyATS, Automatic Testing Solution, or Suite. And more than just automated testing, we're going to be talking about how you can accelerate your net DevOps with test-driven development. Now, we'll talk about that in a little bit more detail, but test-driven development is a methodology that came from the software development world, and it's a pretty recent way to develop software. And it maps very nicely to network automation and programmability with our networks. So we'll do a quick introduction. We'll talk about test-driven development, talk about pyATS, talk about some test cases, and then come to some conclusions. Quick show of hands. I guess before you arrived, has anyone heard of pyATS before you got here? Oh, wow, great. Anyone who had only heard of it since they've been here at Cisco Live? All right, about half, about a split. So that's great, that's great. So, does this sound familiar with when we're architecting or engineering or designing our networks, where we design, we build, and then we test? Sound pretty familiar, right? We come up with our Visios, we plug in the wires, we apply our configs, and then we start testing things. There may be a better approach with test-driven development. Manual processes. A lot of manual processes, a lot of people looking for that holy grail of automation to get away from these manual processes. Lacks instrumentation, real scientific instrumentation. And that's what I would consider pyATS is instrumentation for our network. And we're very reactive. The syslog comes in, the SNMP trap comes in. We're not necessarily testing the health of our network. We're waiting for tickets to arrive that we react to, and then we improve the network performance. Sounds kind of like what we've been doing for the last 15 years or so. So this is a quote that I found from David Amerland from his book, Intentional: How to Live, Love, Work, and Play Meaningfully. Purpose gives meaning to action the same way that structure gives meaning to data. Now, this might not seem like it fits in this deck so far, but we'll come to this idea of structured data from pyATS. So let's quickly talk about test-driven development. This is a software development process that transforms requirements. How many of you have said to the project manager, what are the requirements, right? We live and breathe by requirements as network engineers. We turn those requirements into test cases. Now, the whole idea behind test-driven development, or TDD, is to encourage, one, simple designs. We love simple designs. And two, inspire confidence in our code, especially when we're beginners or if we're network engineers moving into automation. We lack the confidence. We're not sure if it's going to work. We don't know if we're doing it right. We need something to build up our confidence level in our code. This can be extended to networking very easily, a nice parallel path from the software development world into the network engineering world with small modular test cases that we write against the network. Now, this might sound counterintuitive, but with test-driven development, when we write a test, it should fail. We want the test to fail initially. Can you think of maybe why we want the test to fail? Well, how do we know that the test has passed if it's never failed, right? So we start actually with a failed test. Then we write either the code or we implement some configuration in the network to make those tests pass. Now we have the confidence in our code and the confidence in the network. Now, code in TDD is continuously tested against all use cases throughout the development of your code. This is a little different than our design, build, test, where we write complete code and then test everything at the end and it looks good. This is a continuous iteration approach where we write a test, it fails, we make it pass, we add another test, we make it fail and pass, and we're continuously testing all use cases. So if we add a new test case, we know that it's not going to affect any of our previous test cases because we're running all of the tests throughout the full development lifecycle. Now, pyATS. This is the famous image, and we'll spend a little bit of time in here. pyATS is not just one thing. It's a toolkit. It's a framework. It's an amalgamation of tools where we have our toolbox, which is the core testing infrastructure that includes our topology and our test definitions, and our execution and reporting, the foundation of pyATS. In the middle tier, we have the software development kit, formerly known as Genie libraries and Genie framework. This is where we get things like parsers. This is where we get things like models and triggers and verifications. Finally, there is an integration layer. There is a business logic layer at the top of pyATS, where, as you can see, it integrates with Ansible. It integrates with Robot Framework. It integrates with Jenkins and CI/CD pipelines and Azure DevOps. There's a tool called Espresso, which is a free, available to run from Cisco, just like pyATS is free and available to you to run, where, let's say, we have some success with pyATS, but we're starting to build more and more jobs. And we want to schedule these things. And we want to run them continuously. And we want reporting and a dashboard and a GUI. All of that is offered for free from Espresso. So don't be afraid that all I'm going to end up with is a collection of Python scripts somewhere, right? Hundreds of Python scripts that we have to manage and maintain. You can actually bring your jobs into a dashboard which can schedule and report and visualize your pyATS code in Espresso. So let's quickly talk about what is pyATS. Python Automated Test Systems, and it's a Python-based automation framework. Now, this is pretty interesting to me, and this was quite eye-opening when I joined Cisco. I got to know more about this tool. Cisco runs over 3 million tests internally with pyATS monthly, every month, right? So like 36 million tests a year against Cisco's networks are being run with pyATS. So it's for Cisco, it's by Cisco, but you can automate other platforms. It's not just restricted to Cisco technologies. It became available for free to the public in 2017. So it has more than 5 years out in the, it's tested, it's battle hardened, it's been improved and patched and iterated over those time, but it is ready. It is enterprise ready today, given it's been available for the public since 2017. And I guess maybe most importantly, the Cisco executives, the executive team, fully endorse pyATS. And again, it's suitable for agile rapid development iterations and net DevOps. A little bit of marketing there. So how do we get started with pyATS? Is anyone using Ansible? Some people, and we have an inventory, right? Well, pyATS has something what's known as a test bed. And this test bed is sort of self-describing. It is the devices and the topologies that we want to test. Similar, I guess the analogy in Ansible would be the inventory file. So this is used by pyATS to connect to the network. It's a YAML abstraction. This is YAML, not Python, right? And it's just structured text. So it's very easy to build a testbed file. Typically what I see is a static testbed.yaml file that you assemble upfront manually. Now you could take your PuTTY sessions, secure CRT sessions. It has everything you need to build the testbed, right? What's the name of my device? There's a couple of additional fields here beyond, say, PuTTY, like the operating system. This helps pyATS determine which parsing library should be applied against a device given its operating system. We have our credentials, we have our connections. Security-minded folks, hang on, you're just gonna put your enable secret in the clear here? These can be encrypted. So pyATS has something called There is an encryption method on the pyATS documentation where we could either encrypt the whole test bed or encrypt individual variables. I don't want anyone to see my username in the clear. I don't want my password in the clear. I might not even want my IP address in the clear. You can encrypt those variables and decrypt them at runtime, no problem. The other thing for maybe more advanced-minded folks, I don't want to build this test bed. I already have DNA Center, or I already have a source of truth or a netbox or something with all of my inventory. Now I've got to replicate that. What's really neat is that you can dynamically build with Python at runtime these test beds. So make an API call to your source of truth for your inventory and dynamically at runtime assemble this test bed. So two choices there, statically defined test bed, dynamic at runtime. One of my favorite things, and this ties back to that quote about structure gives meaning to data, are the pyATS parsers. So we have two high-level parsers here. We can learn something or we can parse something. So pyATS learn is platform agnostic. And what you do is you say pyATS learn BGP, testbed, testbed.yaml. And it doesn't matter the operating system. pyATS will agnostically gather the state of BGP. It runs multiple show commands under the hood and gives us back a structured JSON payload. Okay, really important. There's 32 available commands, learn OSPF, learn BGP, learn interface. I don't know them all off the top of my head. But you can learn everything about a specific networking object and you get it in structured JSON. Okay? The other thing is parse, and I love parse. There are thousands of these available. I believe over 4,400 parse commands across a variety of platforms. Transforms your traditional show commands, show IP interface brief. Has anyone seen show IP interface brief as JSON? Some people have seen it as JSON versus semi-structured command line standard out, right? Which is the Cisco, CLI dump that you get when you run the command at the command line. Imagine being able to work with that in a structured format like JSON, show interfaces with 50 or 60 sub-items, speed, duplex, etc., MTU, whatever. So let's take a look at this. Even if you don't write any Python at all, no Python, I don't need to know anything about Python, but I want to start using pyATS. This seems pretty cool to get JSON back from our devices. From the Linux command line, pyATS learn OSPF, testbed file, testbed.yaml at the CLI. Instantly, JSON back with your OSPF and everything pyATS has learned about OSPF in JSON. pyATS parse quotes your show command, your testbed file from the CLI. Right away, I have JSON back from show IP interface brief. I haven't written a single line of Python at all. I've done my pip install pyATS, I've built a testbed, and now I can start doing these commands. Now, if you think about this, is it faster to launch PuTTY, find the device, log in, run show IP interface brief, turn PuTTY logging on, grab that text, bring it into Notepad, and then start working with it? Or just run this one-line command and have JSON? And if you're running this inside of VS Code in a terminal, that JSON file can be opened and viewed in VS Code right away. One command. This could be any of the supported show commands you could think of without ever logging into these devices. Now, what if I wanted this from 50 devices? I just add 50 devices to my testbed file. Now I have show IP interface brief or whatever the command is from all of those devices. For those of you that maybe have not seen this magic of structured JSON, this is what that parsed output looks like, right? Nice and structured. I can collapse these inside of VS Code, and it's very easy to read. I don't need to screen scrape and look at the, the tables at the command line anymore. Excuse me. Now, I'll have to come back to this, but okay, So who so far is saying, this all sounds wonderful, this sounds great, but I don't know Python. I don't know any Python, and I'm not really sure or confident in my team's ability to learn Python. There is something called pyATS Blitz, also known as quick triggers. Python-free implementation, pure YAML. A great segue or a great migration path from Ansible, if that's the tool that you're using now, because it's just YAML. It's just structured text. Structured text defines configuration and verification tasks. No Python. Rapid adoption of automation because it's just YAML. No programming experience or expertise required. I love the Python implementation. I've played with Blitz just to check it out. It's pretty good. If you didn't know any Python or wanted to get started or ease your way into pyATS, start with the YAML implementation known as Blitz. Now, if you actually want to write it in Python, where the real power lies, they're known as jobs in pyATS jobs. And a pyATS job is made up of a job file, which is a small control file that loads your test bed and abstracts away the complexity of doing that yourself. And then your actual Python script, where you're going to have a common setup section, connect to the devices, possibly set up a for loop over each device, your testing section, where you write your tests, and then a common cleanup where we not only do we disconnect gracefully, but we try to ensure that we left the network in the same healthy state as when we first connected to it. So that's sort of the three parts of a pyATS job, is your common setup, your testing section, your common cleanup. So here's just a quick, I know it's hard to read this on the screen, but for each device in testbed, device.connect. And pyATS does this with lots of things. Device.something, function, right? Device.configure, device.learn, device.parse. You could have all of this in this for loop. For each device in the test bed, first connect, and then here, right, set up a variable to contain device.parse, show IP interface brief. Another variable to hold the learning of OSPF. And then we just print those to the screen, right? So .connect, .parse, .learn. Pretty straightforward stuff. Let's talk about some test cases. I'm just going to check the time. Okay, good. So pyATS testing. Remember that structured JSON I showed you? And show IP interface brief has, is interface okay? Yes or no? That could be tested. We can test any JSON key or value. So you're telling me I can parse show IP interface brief and then write a little function that says if interface dot is okay does not equal yes, fail the test. So now you can run that across your entire network, right? And if it says no, then I know it's not okay, and I fail that test. And it's a Boolean pass or fail. That's it. It's either pass or fail. There's no in between. We can do string comparisons, duplex, mode, half. Probably not good on the network in 2023 to have half duplex ports out there, right? So why don't we learn interfaces and then test each interface and do a string comparison if duplex mode does not equal full, fail the test. And this goes on and on and on. CRC errors, input-output errors, layer one things that are like, what do you have operators logging into each switch doing show interface looking for CRC errors? Does anyone even care about CRC errors until a link fails? It's not something we really think about because we haven't had the instrumentation. Now we have the tools to test 100,000 interfaces, and then my report would say, here are 30 interfaces that are half duplex. Here's 40 interfaces with CRC errors. And now we have that sense of what is healthy and what is not automatically. And we can test integers as well, greater than, less than. What I like to do with the integers is set up a threshold, right? So there's a ping reachability test with pyATS where it will give you the ping results in JSON with a minimum, maximum, average round time and success rate. So what I usually would do is say, you know, the ping percentage success rate threshold is 100. And if any of my ping tests is less than that threshold, fail the test, right? Even the average response time, how come this is taking 45 seconds round trip, right? There's something not right with this link. And it becomes self-evident because we're using automated testing to drive that information to our operators. Okay, I sort of gave it away, but who thinks it's just testing, right? Is pyATS just a testing tool? Is that all I can do with tests or with the tool is test things? You can do configuration management with pyATS. Remember those .connect, .learn, .parse? .configure is a method inside of your job. You can do static configurations as a string. You can use Jinja 2 templated configurations from pyATS. There's an API for that, really easy to do. And there's other pyATS APIs. So, right, this device should have 4 CDP neighbors. If CDP neighbors, and I parse, show CDP neighbors, and if it's less than 4, fail the test. Well, then I could come in and say, what if I try to self-remediate that network? .configure, shut. .configure, no shut. That's usually what you would do, right? Bounce the port. Well, why not bounce the port as part of your testing job if it fails the test? And then back to the templated config, what if we go a step further? What if I know there's a golden config for that interface that should be applied? So I bounce the port, I retest. CDP neighbors is still less than 4. Okay, well then let's shut the port, default the port, push our golden templated config to the port, no shut it, and retest it. Now, if you've exhausted your possibilities at some point, but you can build that self-healing network in, or even zero-touch provisioning or greenfield development. You could build a pyATS job to push configurations. pyATS also offers differentials. If you've done a Git diff or a Linux diff and you have the plus minus Linux output. So, is it on my next slide? Here's an example of a configuration job. We're going to connect to device or devices. Let's capture the pre-change state as JSON. And that could be the pre-change configuration, right? Parse config, learn config. It could be state, parse show IP interface brief, parse show IP OSPF, neighbors, whatever it is you want to do. Capture that up front. Configure, push your configs. Run your show commands. Run your test of your device before you change it, right? So ensure a healthy state before you change anything. If any of these tests fail, don't configure anything. Just let me know that the device is not ready for these changes. Finally, push your configs to your device. So I've captured the state, I've tested it, looks good. Let's push some config to the device. Then we can recapture, just redo these first steps. Post-change state capture, retest. Did I break anything with this configuration step? Are all of my tests still passing post-config? Yes or no? And again, maybe there's a no. Maybe we're failing some tests post-config. Use the .configure maybe to roll back, possibly. Finally, perform that differential, and it will show you what you've added or removed from your pre and post deltas. Now, in a day-to-day mode, imagine that. Every morning, we're capturing the state and we're testing. Every single morning. Tomorrow morning, tickets start coming in. What changed? Is that not the first thing you ask yourself on the network? What has changed? Something has changed. Things don't just stop working. So we do the diff, and we go, someone removed a route. Someone added an ACL. Whatever has changed. And then and we reduce the mean time to innocence. It's not us. It's not the network. We want to reduce that mean time to innocence. And these differentials, if you run them daily and have your operators just do a quick check, you'll know the state of your network over time. The other thing is that I really like, and one of the big advantages of this tool over some of the other automation tools I've used, is the pyATS log viewer. This is an interactive HTML report, including the CLI logs. So when you launch the log viewer, it will give you all of the tests passed or failed in red and green, and it's beautiful. You can click on a failed test, and then in the panel on the side, it will show you the CLI test that you ran and why it failed. These logs can be exported. You could host them on an Apache server or on a web server somewhere. You can archive them. You could move them into Git. So I take my logs after every job and I put them into my Git repository. And now I have a full version and source control history over my pyATS jobs. Notifications. pyATS is actually WebEx integrated. When I showed you the CLI command, you can actually add --WebEx room --WebEx token, and the report that you get at the end of your pyATS job will go to your WebEx room that you specify. So there's a lot of ways you could maybe take advantage of that. A WebEx room for your operators, or a WebEx room for a certain class of devices that we send the failure notices in from the job. It's really handy to get it right on your phone. Oh, hang on, I've lost CDP neighbors. Well, how do you know? Well, the Espresso CDP test that I run every 4 hours has sent me a WebEx directly telling me I've lost a CDP neighbor. Conclusion. Now look at the timing. Okay, so transform your approach to design, test, and then build. Right? Let's switch the test and build, and test up front. Add the confidence to your code and the reassurance to your design with this test-driven development approach. And you can test at scale for very granular values. CRC errors, half duplex, we've mentioned some of these, automatically and with reporting. And again, snapshot, test, change, retest, snapshot, differentials. Nice repeatable workflow for this approach. So thank you for joining me. I hope that was helpful. We have a minute or two if anyone has any questions. Is there anything that maybe stands out? If anyone feels brave enough to ask me a question, feel free. Yes. Yes, because you have the operating system key. You have aliases. So yes, you can override that testbed and focus on specific classes of devices. It's a great question. Oh, I'm sorry, I didn't quite catch that. Yes, it's very fast under the hood. pyATS is extremely fast to connect. Yeah, and yes, go ahead. Oh, from SNMP? Well, you don't get that structured payload as JSON. I think that would be the key difference. It's structured differently, but it's not the JavaScript object notation structure. No, I wouldn't say so. It's no more resource intensive than a human logging in and running those commands. Yeah. Yes. That's a good question. I don't think so. I think you would just maybe have different test beds, possibly for your groups of devices. So you could have multiple test beds. It doesn't need to be a single test bed with every single device. Sequential process, yeah. The other thing I'll mention for more advanced people wondering about things like parallel calls and doing things in parallel, pyATS supports P calls, parallel calls. So, and some commands use parallel calls without any special coding. So for example, when I learn pyATS from the CLI, pyATS learn, and then my test bed, that's actually in parallel. So it's very, very fast and it scales very, very well. Oh yes, we have a raffle here. And the winner is 397. 397. 397. Okay, going once. How about 399? Okay, great. Come on up. And if you would indulge me, I'm going to take a quick selfie with the crowd because this was really exciting for me. And I'm going to rotate that. And okay, everybody wave. Okay, thank you so much. Thanks for joining me today. Thank you.